Good afternoon. My name is Fergus McKee. I'm from MEDIC, which is IDEA, works the applied research arm of Merkel College, and I'll be serving as the moderator for today's session. It's my pleasure to welcome Mohammed Hussain, who runs his own consultancy firm, Techie Maestro, to FHIR North. Mohammed Hussain is an independent consultant in medical imaging informatics. He serves multiple roles, among which is the technical project manager of the SIIM hackathon, as well as the RSNA Imaging AI in Practice demonstration. A software developer by training, he stumbled into medical imaging informatics more than a decade ago and found his purpose there, never losing sight of the important role IoT can play in improving patient care. Mohammed is a keen advocate of interoperability in healthcare and a big supporter of open source software. We can be taking questions during or at the end of the session. So please ask your questions via the Q&A function. If you do use that, please drop your name so I can attribute the question to you. Or you can drop them into feed loop and we'll pick up your question there as well. A few housekeeping notes. The chat is a virtual event platform. It will be monitored by our event staff. Please use it to post your questions and let us know if you're having any technical issues or want to chat with each other. The session is being recorded, assuming no technical difficulties, and will be uploaded within the next week. Closed captioning is available at the bottom of your screen. So without further ado, welcome Mohammed.
Thank you so much, Fergus. I appreciate the introduction and very, very happy to be here at FHIR North, one of my favorite conferences of the year. I should start by explaining the title I have in my presentation. So a bunch of people here may or may not have heard about DICOM, and a bunch of people may have or not have noticed the word imaging informatics. So people like me, I was telling Fergus before we started the call, people like me live in this imaging informatics little corner of the world. We're in our little niche. And we usually like to come to these FHIR conferences and remind people that, hey, we exist, we're kind of in a bit of a corner. But today is the day where I explain to you what it is that we do, what you need to know about DICOM, and how you can work with it. I generally have this introduction slide, but Fergus has already covered most of it. There's a much younger version of myself over there. I like that picture. I kept it for that reason. I'm very pleased to be here. So imaging is an important corner of the healthcare continuum. If you think about it, with your patient hat on, most of the time when you end up going to see the doctor, whether it's your family doctor or your emergency room doctor, more often than not, you're going to be end up sent for imaging, whether it's getting an X-ray done or something else like a CAT scan or MRI or an ultrasound. It's a very typical workflow. It's very hard sometimes to diagnose things without imaging. So imaging exists for a very good reason, and it's very different from the rest of healthcare for reasons we'll explore today. Let's work through an example of what this looks like in real life. So let's say myself, I had a problem. Let's say I had a cough. So I went and got myself into the emergency room at my local hospital, and then I was seen by the emergency room doctor. That emergency room doctor decided, hey, I'd really like to get an X-ray of Mohammed's chest. So then he creates an order. That order is then sent to the radiology department. And here's where it starts to get interesting, because to a lot of the common folks, a lot of the patients, a lot of them don't realize there's such a thing as a radiology department. And if they do, to them, it's basically just a collection of machines, X-ray machines, CAT scan machines, and technologists who actually run these machines. But this is where it gets interesting. This order will get reviewed by somebody within the radiology department. And depending on the complexity of the order, so something like a chest X-ray is very typical, so they probably wouldn't think about it twice. But if this was something like a chest CAT scan or a brain CAT scan, then this would actually have to be reviewed in a more thorough manner, and they may actually adjust the parameters of the exam, which is what's called the protocol. Now, the person who reviews this could either be the technologist who's running the machine or the actual radiologist who is a doctor actually trained in a specialty called the radiology. Now, once that's done, the patient is then called in. They're put into the machine or against the machine, depending on the top of the machine. The images are acquired. Then these images are quote unquote read by the radiologist. So the act of reading here involves the radiologist bringing up your images on a specialized workstation and then transcribing what they see within the image into a written report. This report is generally the final product of the radiology department. So that report is then what trickles down to all the downstream systems called the distribution. So a copy will go back to that ER doctor that you saw first, a copy would go to your family doctor, and then any other doctor that you may end up seeing. So for example, say they actually find something in my lungs, they refer me to a specialist, that specialist will end up getting a copy of that report. Now, the interesting part about this workflow is that a lot of you with backgrounds in health informatics recognize a lot of this workflow can be performed using HL7 version 2 or HL7 FHIR, except for this corner. And do forgive me because I'm oversimplifying. This is not exactly black and white, but I'm oversimplifying. This one little corner here is DICOM. The rest is HL7 V2, FHIR, what have you. This one corner is the DICOM. DICOM is the format that is used for capturing images, typically in a radiology department, but it's expanding beyond radiology departments, and we're going to explore that in a moment. So at a high level, as a patient, my medical record consists of the following. The first one is EMR data, whether that is transmitted or stored in HL7 version 2 or FHIR. It would also have imaging data, which, contrary to what people believe, is not just literally images. There can actually be metadata related to images. So DICOM can store images, but can actually store other metadata objects. For example, if I get a CAT scan, they have to record the amount of radiation dose that I got, because that's how X-ray and CAT scanners work. They actually expose you to X-ray, which is radiation, and that exposure has to be recorded and tallied up for ensuring that you don't get overexposed. The medical record can contain other evidence documents. I have no examples because thankfully a lot of these are now gone. These are things that actually used to be not captured anywhere or sometimes captured on paper, like a requisition form or something along those lines. Thankfully, that's all gone now, or almost all gone now. Now, what is important to know from this slide is when to use when. So when you want EMR type data, clinical data, lab results, orders, patient records, etc., that stuff resides in the EMR. So that would be an HL7 version 2 or FHIR message. Anything imaging would be in DICOM. And as I said, DICOM can store images plus non-image objects that are related to images as well. So it is important to remember that DICOM is the standard for imaging, even though it can store non-image data, but it's the de facto standard for imaging, and that DICOM is not specific to radiology. A lot of people tend to think of DICOM as radiology. It may have been true many, many years ago because radiology was the specialty that was at the front of technology. So they were ahead of everybody. They went digital, they went computerized, but now everybody else is catching up. So other specialties are coming on board. And if you look on my right-hand side, you're going to see a number of examples. So there's pathology, which is actually very, very interesting because the images they bring to the table are massive. These pathology images, whole slide image images, usually start around 300 megabytes in size for an individual image. You also have specialties like dermatology, where they just take a picture with a camera and try and record that in your record. Wound care, where it could be the patient that actually submits pictures just to show the progress of their wound healing. And then last but not least, you have cardiology, which traditionally has been the specialty closest behind radiology from a technology adoption. Now, cardiology is actually an interesting one because cardiology will store images. They'll often perform exams using modalities like an ultrasound, but they also will store non-image data, like in this case, it's an ECG. So that's actually not stored as image. That's actually stored as vector data, but can be stored in a DICOM container. So it's very interesting to note. Now, what's important to note also here, DICOM is the standard for imaging, but it's also very flexible to store a wide variety of images. For example, the ones you see here are captured using what's called visible light, kind of like your camera. But the traditional radiology images are actually typically captured using non-visible light. For example, X-ray, using literally X-ray, MRI, using magnets and magnetic resonance, and ultrasound, which literally uses ultrasound. So remember that the physics play a big role in what you find within a DICOM image or object. Just like FHIR, there is a relationship between all the entities or resources in DICOM. So in this case, it's a DICOM hierarchy. So let's take, for example, myself as a patient right here. So there is me. I would have had any number of studies over the course of my life. So say, for example, I had that chest x-ray that we talked about earlier in the hospital example. And that chest x-ray, so that's a study or an exam. Within that, there'll be two series. Now, chest x-rays are nice examples for this because they're the simplest. So for example, you see there AP. AP is an x-ray taken in this axis versus lateral, which is taken sideways, as you can see me. Hopefully you can see me in the camera. And then you'll have something like an ultrasound. And this is just an example, so it's not exactly 100% correct. But in ultrasound, you have the option of capturing sequences of objects or images. So in this case, the technologist may look for my liver, capture a sequence or two of my liver, and then maybe look for my kidneys and then capture a sequence or two of my kidneys. And then these are called instances. Within the instances, you can also have frames. It's not super important that you know the distinction right now, but it's just something important to keep in mind for the future, in case you actually do end up working with DICOM. And then last but not least, you have a study like a lung CT. In this case, I kept it simple. It's just one sequence, and then it could be any number of frames. Now, you may say that, why are there frames here on the ultrasound, but the frames in the lung CT are stored separately? There is a long answer to that, but the short answer is progression of the standard. So it's not that one is right, the other is wrong. It's just, there's a lot of history, and we'll talk about the history in just a moment. Now, one of the cool things about DICOM is that even though it's a format that was built to store images, the actual DICOM object is actually made up of what's called a header, which is a bunch of metadata, and then the actual pixel binary data of the image. And that's one of the founding principles of DICOM, is that image and metadata are always stuck together. They're never separated. So what that means is, if a system failure happens and you end up having to recover, let's say, things out of disk because the database crashed, you would actually have information that allows you to reconstruct your index based on that header metadata. So if you go down the hierarchy, just examples of things that you'll find in the header, you're going to find the patient name, date of birth, gender. As you go down to the study or exam level, there will be identifiers for the study, for example, like session number, the date the study was performed, the description that tells us the reason for the study usually and the type of study it's being done. And then you go down to the series, the identifiers, the modality, so the actual machine type that was used to capture this exam, the body part that was being examined, and then all the way down to the images, where you can, for example, track the height and width of an image, the patient position for those digital modalities. You can actually track the patient's positions using cosines and whatnot. Now, DICOM, depending on how you were exposed to it, can seem sometimes like just a bunch of files that exist on disk. But the reality is the DICOM standard is actually a lot bigger than that. In fact, the DICOM standard not only defines how instances are persisted on disk, but it also defines communication protocol. So again, similar thing to FHIR, where you can persist things in JSON format or XML format, but then there's the RESTful APIs. Except that with DICOM, DICOM is actually evolved as a standard for a very long time, and it's generally backwards compatible all the way back to its original inception, which is in the 90s. Of course, that has advantages, disadvantages. I'm going to cover more of the advantages here. So there is the original protocol, which is DICOM DIMC, sometimes called, and then there is a new version, which is DICOM Web. So the big difference is DIMC was kind of specific to DICOM. It was built on top of TCP/IP, but it's got its own syntax and communication format, whereas DICOM Web has gone fully RESTful. Now, DICOM has a whole slew of operations. I'm covering these three here just to get an example. So these transactions have names. So for a query, when you want to do a search, you want to search for studies for patient Hussein or what have you. In the DIMC world, you would have performed a cfind, Whereas in the DICOM web world, you would prefer a Keto RS. And you notice all of these have RS because that's short for RESTful service. But these are the different transactions. So if you ever talk to DICOM people, you're going to hear them throw words like cfind, cmove, cstore around. That's what these terms mean. So the query is searching. Retrieve is when you get a copy of the data. And then a store is when you're creating new data into the server. So in HTTP verbs that FHIR people would understand better, query would be a get. Retrieve would be essentially another get, but in this case, you're getting the full data rather than just search results. And then a store would be a post. I should point out to the audience that I'm happy to take questions at any point. You do not have to hold your questions until the end of the presentation. Feel free to put your questions in the chat or Q&A feature, and I will answer them as I see them. The big question I usually get when I present on DICOM to the FHIR crowd is, why couldn't we just do all of this in FHIR? Why couldn't we just stick the images into FHIR objects and call it a day? We just simply do without DICOM. The answer to that question is, there are really, really, really good reasons why that happens. I'm going to tell you some, but I can't cover all of them in the short span that I have here today. One of the reasons is the scale. These images are complicated. These images are not just basic JPEG files like you get out of your phone camera or whatnot. A lot of the time, these images are massive in size. They're in hundreds of megabytes. A lot of the time, these images are not 8-bit images. They are 12 or even 16-bit images. So there's a whole level of complexity. The other thing is, DICOM has been around since the early 90s. So it was incepted around the same time as HL7 version 2. And one of the cool things about DICOM, you heard me say, is it's backwards compatible. Unlike V2 versus FHIR, which are basically pretty much mutually exclusive. DICOM, if you found a system that was implemented in the early 90s, you'd still be able to communicate with it, and you'd still be able to get DICOM objects and view them. So that stuff isn't stuff you can easily move over to FHIR, because guess what? If that had been easy, we would have stopped using V2 a long time ago, and we would have moved everything to FHIR already. And don't get me wrong, I myself would love to see V2 go away, but it's just not happening anytime soon. So long story short, DICOM exists for a very good reason. It's not that imaging people like me are being stubborn. We're not holding out on FHIR. We're all actually very excited for FHIR just as much as everybody else. But DICOM is a little special and needs to exist for a reason. Other thing I'll also add as far as DICOM goes is, behind the scenes, DICOM systems like PACS do a whole lot that is more than just meets the eye. Again, I can't go into these details today, but just something to keep in mind. Now I do see.
Sorry, just a question just popped up here. Does bone density follow the same rules you described about the other modalities?
That's an excellent question. I'm not an expert in the area, but I will tell you, based on the limited examples I've seen, DICOM density machines, bone density machines do generate DICOM, although the examples I've seen are probably the saddest implementations of DICOM, because what they'll do is they'll create this report that almost looks like a PDF document with a bunch of text and a bunch of images, but it's literally pixel data. So I personally find that very sad, because I feel like that should have been a combination of metadata and images, that this way you can then parse that data into something more useful. But that's a whole different topic for another day. Long story short is, yes, they generally generate DICOM data that end up in PACS, and they end up being used by the radiologist in the PACS system.
Okay, great. Thank you for that.
No problem. So hopefully by now you would have understood that DICOM exists for a good reason. And I'm going to go ahead and press forward with how you can actually go ahead and use it. So first things first, we got to explore the link between FHIR and DICOM. And a lot of you have probably encountered this little resource called Imaging Study. That's generally kind of the link of where it goes. Now, where you draw the line for who implements an imaging study, is it the EMR or is it the PACS system, is complicated. What I'm seeing so far is that the EMR vendor seems to be shying away from implementing the imaging study resource. And basically what they do is they'll defer to PACS, so that if you wanted to read an imaging study, you'd actually go to the PACS system and say, hey, tell me about the imaging studies you have. So those PAC systems would then have a FHIR interface that you could use to query and be able to get stuff. But again, it doesn't mean that an EMR couldn't potentially implement this. If I have time in a moment, I'm actually going to go to the FHIR website and walk through this in more detail. But at a very high level, you have an imaging study, which can contain a number of series, which then can contain a number of instances. So that kind of maps pretty nicely to the hierarchy I showed you earlier. So study, series, and then images or instances. You can use the word interchangeably for what we want to do here. Using the word imaging is a gross simplification, just because a DICOM object, as I've told you before, may not always be an image. So instance is the generic, politically correct term. It basically means it's a DICOM object, which could be either an image or a metadata object, like an ECG or radiation dose report or something along those lines. The other important one is the endpoint. So in FHIR, the endpoint resource is basically something that allows you to link to any other API endpoint. In this particular case, an imaging study can link to an endpoint. So this way, you're working your way through the patient record and you want to be able to get the actual DICOM. You can then follow the endpoint to figure out, well, this is the API endpoint, this is what dialects it speaks, and so on and so forth, and then you figure it out from there. Beyond those, there are a number of FHIR resources that apply in imaging, even though they're not imaging specific. So one of those is the observation resource, and there is a lot of movement in the imaging world right now to try and encode a lot of our findings in machine readable formats and then stick them into the EMR using things like observations. So they could be data mined and understood by downstream systems, training AI, what have you, so on and so forth. And then we've talked before that the final product of radiology is that written report. So that's literally a diagnostic report in FHIR terms. So I promised a quick tour of FHIR.org, and here is an imaging study resource. Again, I'm looking at R4 because generally that's the most relevant version at this point, just because that's what most EMR systems, PAC systems implement. It's your stereotypical FHIR resource. You've got identifiers at the top, so you can store as many of these. In this particular case, because this is an intersection between FHIR and imaging, this typically will contain something that's called an image study UID, which is the unique identifier that DICOM uses under the hood. It is not typically a human readable identifier. The other one under the hood is usually human readable. It's called an accession number, but accession numbers are not guaranteed to be unique. So this will typically, you expect to find at least these two values in it, the study instance UID, as well as the accession number. A study can have a status, I'm not going to get into that. A study can have any number of modalities. So a study could have one or more modalities. So you could store these here too. Here you can link back to the patient for which the study was performed, the encounter, the date or time the study was started, and that typically will just map to the DICOM date, study date time. The order the study was based on, which in FHIR terminology would be a service request. I'm going to skip, but here you see the endpoint. And if I go to that tab over here, so here's the endpoint. So there's a connection type. This would tell you, for example, what type of transactions the server supports. And those fancy DICOM transactions I showed you earlier, as you can see, are all listed here. So there's WADO-RS, PEDO-RS, STO-RS, and then there's the older version of WADO. I'm not going to go into that level of detail. So this would allow you to figure out, okay, well, this particular endpoint speaks the following different types of transactions. I can ask it for these following different things, and so on and so forth. If I scroll down, you'll also notice that if I choose to, I can put information about the individual series within my imaging study resource. And in fact, if I'm that detail oriented, I can even go down to the instance level and record information about the individual instances. Again, instances are essentially the generic objects, which typically are images, but in some cases could be other than images. And I do see.
sorry, just to interrupt you again, just got another question just come from the QA. So can structured and synoptic reports be handled in FHIR?
Yeah, indeed. In fact, I would go out on a limb here and say that I don't think there's actually any decent handling for them in DICOM. So I would say that FHIR is definitely the way to go for synoptic reports.
Considering the FHIR conference, that was a great answer.
That's right.
I'll let you carry on. Thank you.
Thank you. Now, I will tell you, as you can imagine, this resource defines a lot of attributes. So obviously, your mileage will vary as far as what the server you deal with will actually implement. For example, will it implement the actual series listing and then instance listing? Your mileage may vary, but the typical core attributes will usually be there. Things like an accession number, a study instance UID, number of series, number of instances within the study. These are generally pretty widely adopted, so they should be somewhat reliable. All right, so in R5, we are pleased to welcome the imaging selection resource. I can't speak on in a lot of detail about this, but I will say it's an exciting development, and in a moment we'll talk about the details of why. But that's actually one resource that was added in R5 specifically for imaging informatics, and it actually serves some pretty cool use cases. Again, I'll cover those in a few moments. But of course, we're also happy to see that imaging study has climbed up the maturity model ladder. It was a level 3 before, and now it's a level 4. So it's nice to see that these things are becoming very, very mature. Between the imaging community, the DICOM geeks like myself, and the FHIR community, I'm kind of actually in the middle, to be honest. But anyway, there's actually a lot of common stuff that's in between that applies to both of us. One of those is FHIRcast. For those of you who are not familiar with FHIRcast, it's a standard that allows for synchronization between the multiple systems open on somebody's workstation, so context synchronization. So that's really cool. Smart on FHIR for EMR launch in context, also super cool. CDS hooks apply a lot. For example, that step I talked about earlier when the order comes into the radiology department and they have to refine the parameters of the order to create a protocol for the study. That's very commonly nowadays implemented using CDS hooks. And then in between the two communities, there are a whole bunch of FHIR implementation guides that are looking at translating data that traditionally only existed in DICOM over to FHIR. Again, we're not talking about images here, we're talking about other data that can be mined and used by downstream systems. So one of those examples is radiation exposure. There's an implementation group that's taking these radiation exposure reports, which traditionally were only generated in DICOM, and trying to figure out a way to translate those into FHIR observation resources so that that information can then be persisted by the EMR and potentially send downstreams to other interested systems. If you decide to pick up DICOM and do some work with DICOM, maybe you want to image enable your application, I do have 3 bits of advice that I hope you follow. Number 1 is do not reinvent the wheel, use a toolkit. That's definitely true for FHIR, but I would say it's a lot more true for DICOM. Do not be tempted to say, oh yeah, I can easily parse this, I'll figure it out. Use a toolkit. There's a lot of nuances under the hood with DICOM. 100% use a toolkit. Even if you're using this in a sandbox, there are toolkits that have command line executables that you could use, which will save you a lot of hassle and grief. You may have heard me say this in the presentation, but I cannot repeat this enough. A lot of people tend to suffer from observer bias when it comes to DICOM, because somebody comes and hands you a bunch of DICOM files and people assume that that's all there is to DICOM. These objects that you were given are a snapshot of something, but in the real world, these objects have a life of their own. So just remember that. This is, again, no different than FHIR. Somebody hands you a copy of a patient resource. It's possible that patient resource has been updated on the source server since last time you looked at it. So remember that's true for DICOM as well. DICOM has a concept of subclasses, which are different ways of storing data. Again, different types of images, different types of metadata. And then even if it's image with pixel data, it has different compressions. And these are always evolving. So when you're reading DICOM data, it's important that you do good error handling so that if you encounter something your code was not built to handle, you at least can recover gracefully. Again, it's an old standard that's been modernized over and over since the 90s. So obviously, since the 90s, a number of things have been deprecated and a number of things have been added, and it's constantly evolving. So real world use cases where the two come in hand, both FHIR and DICOM. So the typical ones are image enabling the EMR. So the ability to start in the patient record in the EMR and be able to get to images pretty quickly. Whether you do that through FHIRcast or Smart on FHIR or something else, but that's a really good use case because that then gives you a comprehensive health record, which results in better care coordination. So even though the primary audience for DICOM images are the radiologists, it's not that the other doctors don't understand these images or don't care for them. So if you give them access to those images, you're actually enabling them to do more and take better care of their patients. With the advent of artificial intelligence, we're also now starting to see the concept of a multimodal artificial intelligence or deep learning models. So they are models that could look at images, but then also take into account, patient records. So for example, you have an AI model that looks for lung cancer. It can then tap into the EMR and see if that patient has a history of smoking, because that then gives them a higher chance of getting lung cancer, and so on and so forth. Data sharing across multiple health institutions is a big use case. We're lucky, those of us who live in Ontario, that we have nice implementations of this that exist already, but it's not true everywhere. So that's pretty important. And then last but not least, patient access to records and images. I'm a big fan of the patient engagement movement, and this would definitely apply here. I highly believe in patients having access to their records so they can actually be on top of their health issues, treatments, etc. And also the option of asking for a second opinion. That's always good to have as well. Now, beyond the typical integration use cases, let's talk about use cases that are evolving and constantly coming up. So here we have to talk about something called integrating the health enterprise, which is IHE. Hopefully most of you would have heard of IHE by now, but if you haven't, IHE is an organization that is it's a joint organization sponsored by a number of bodies. Among those bodies are HIMSS and RSNA. So two bodies that look after HIMSS obviously is healthcare informatics, and then RSNA is the radiology body. But again, it's not specific to radiology, but they do this. What IHE does is they create integration profiles. People will often refer to them as standards, but they're slightly different. So IHE creates integration profiles that sit on top of standards. So an IHE profile will use tools like DICOM, HL7 version 2, FHIR to identify a solution to a workflow. For example, that very first slide I showed you of the patient coming in, getting the order, getting scanned, whatnot, this would be a typical workflow that IHE profiles would describe. Now, IHE is an organization, as I said, that looks after integration profiles for all of healthcare. So IHE has a concept of domains. Radiology is one of them, actually the most active one, but they look after a number of other domains. So for example, they have a domain in dentistry as an example. IHE is constantly defining profiles. And today I actually want to show you a few of them that I think are relevant for anybody that's interested in imaging. So AI results right here is a profile that came out a few years ago and was recently updated. Now, some of these profiles may not necessarily dictate using FHIR immediately. And in this case, like for example, AIR, the results may come out in DICOM format, but then there you'll find an implementation guide that has some kind of one-to-one mapping, or at least some form of one-way mapping that can map that DICOM data into FHIR elements. So that would be pretty relevant here, because now we can take the results from AI models that are looking at images and analyzing these, and then be able to encode that in a language and format that the EMR and other downstream systems can understand, systems that don't typically speak DICOM. IMR, interactive multimedia reporting, is another one. Very exciting. This one came out a year ago. I am personally very, very excited about this one because reports are probably the biggest thing that hasn't changed a whole lot since the digitization of radiology. They've changed, but not a lot. Interactive multimedia reporting is taking them to the next level. They're now going from these static, boring documents to more readable interactive documents. So for example, if a radiologist is looking at a lung scan, a CT, and they see a nodule, they can now in the report create a hyperlink that would take you to the exact image and location where they saw that lung nodule, which is super helpful, especially for everybody downstream that's consuming that information, whether it's the patient looking at their own record or the other doctor, for example, the oncologist who's actually looking to treat it. You're now creating a much easier way for people to collaborate. This one literally just came out, I think, within the last 2 weeks, integrated reporting applications. So this one here actually makes a lot of use of FHIR and that imaging selection resource that I said just came out in FHIR R5. This one here looks after what happens if on the radiologist workstation, we've got a bunch of things running. So you have the EMR, PACS where they're reading images, reporting software. It's possible that they're in the PACS system measuring these nodules, and they want to be able to send these measurements into the report right away. In the past, this was either done manually, they literally had to type it into the report on their own or dictate it with a microphone, or if it flowed, it would flow server to server, which was never fast enough. So with integrated reporting applications, IRA, you now have the option of these things being possible in real time, which is, again, a big shift. There are even cooler use cases, like, for example, AI here could also play into it, but I don't have the time to get into it. A bunch of other profiles you're welcome to look into if you wanted. They're not necessarily super straight FHIR specific, but good to know for awareness. And I should point out that just like HL7 with their connectathons, IHE does hold connectathons. This is an actual picture from one of these connectathons. They're really, really cool. So if you have an interest in any of these workflows and integration profiles, I would highly recommend going to one of those connectathons. If you want to try out DICOM Web and how it connects with FHIR, you have a bunch of options. I'm, of course, very partial to the first one because I'm very involved with SIM. But the SIM hackathon has a server, dataset, and documentation that anybody could use for free. The server requires an API key to use, but that's also free to obtain. You do not have to be a member of SIM. Even if you don't use the server, you're still welcome to use the dataset. It's a unique dataset because it combines EMR, FHIR data with DICOM imaging data to give you the full picture. And you're also welcome to use the documentation as well. If you don't want to use that, there are some nice open source DICOM implementations you see here, Orthanc and DCM for Chi, the new one, not the old one. And of course, you have these freemium cloud type services like Google, Microsoft, and etc. And with that, I thank you all for your attention. Happy to take questions. And if anybody thinks of questions afterwards, you see my email on the screen. So feel free to reach out and ask any questions.
Thank you very much, Mohammed. We do have one question that's come into the Q&A so far. So FHIR can be used to manage imaging related data, but in order to retrieve actual imaging data, it has to integrate with DICOM. Is that correct?
That is correct, indeed. The one distinction I'll make is that it's not that FHIR itself will go and fetch things from DICOM, it's that you, the consumer of that information, would trickle from FHIR to DICOM to get the information you need.
Okay, well, thank you for that clarification there. So, yeah, if the audience got any other questions, then please feel free to drop them in the Q&A or the chat. Whilst we wait for some of those to come through, just a couple of questions here. What's your recommendations for anyone interested in learning more about DICOM and medical imaging workflows?
Yeah, that's a good question. Definitely check out the DICOM website. The other one is SIM, because SIM is actually a community of people like myself who have interest in FHIR as well as DICOM, but a community also includes clinical people. And even if you don't want to go attend the actual SIM conference, there's still a whole lot of year-round resources that you'd find very, very useful. And last but not least, feel free to ask people, myself included. We'll be happy to point you around to other resources and things you could try.
Okay, and thank you for clarifying that it's SIM, not SSI, SII, as I
It's
said
the
in the
same
intro. Okay. Well, what are the current challenges and trends in medical imaging nowadays versus the rest of healthcare?
That's a great question, Fergus. It's some of them are different and some of them are no different. So obviously the elephant in the room is AI. You know, everybody, whether you're in the general health informatics world or in imaging, everybody's talking AI. I personally have mixed feelings. On one hand, I'm excited for all the possibilities that it can bring to the table, but the other hand, I feel a little disheartened by the hype that everybody's drumming up without it actually being able to deliver this yet. So I do see it getting there one day, but we're just not quite there yet. That's one. The other one is there are other interesting trends. For example, we talked about the reports. Reports right now are pretty boring. With the advent of these new integration profiles, they're going to be a lot more interesting, more consumable to other people. These reports can also be a treasure mine. So if you can inject more semantics into these reports as far as coding systems, they can be mined to inform more things downstream. And then these reports often contain things like follow-up recommendations. And now we're starting to see more and more of these systems that can automate identification of these follow-ups, and they can actually nag the patient, the primary care physician, to say, hey, they saw something they should come back for in 3 months. Believe it or not, for the longest time, a lot of these things were missed. I think research said 40% of them would fall through the cracks, which is pretty scary, but it's being solved right now as we speak.
Okay, we've just got a couple more questions that come in. I'm conscious we've only got a couple more minutes as well, so I might wrap with you sort of relatively quickly. When treating DICOM images, will there be more integration in the future between FHIR and DICOM endpoints?
Yeah, that's a good question. I don't know what your definition of more integration would be. More integration could mean different things to different people. I would say the reason they're not more integrated today is just because they typically tend to be distinct system, right? So the EMR will tend to speak FHIR versus PACS will then tend to speak DICOM. Again, it's not a cut and dry line, but that's generally what it is. So it's not a disconnect per se, but it's a different use case, I think is what it is.
Okay, finally, we've also got one more. It's just more kind of a statement. So I think it feels more like an exam question. Outcomes and reports are still not standardized. Need NLP. I think this should be full stop discuss.
Yeah, that's a great point. I agree, but not fully. So I agree they're not standardized, and there's definitely work that could be done to clean them up, make them more useful. My opinion, and where I slightly disagree, is NLP. I think NLP and fuzzy logic type of stuff is good for a short-term solution, but long-term, I personally want to see reports being created in a more, as I said, semantic fashion, so that you've got code, you got identifiable findings, recommendations, etc. That will actually clean it up.
Okay, I think we're just about out of time. So I think we'll just wrap it up at this point. So thank you very much, Mohammed. It was a fantastic talk you just gave. It was very enlightening. So thank you for all your time today. And thank you to the audience members as well. And thank you for all the questions that came through. So I hope you enjoy the rest of the conference, which is just the final keynote from Sheridan Cook, which is starting now. And I'm very keen to see how she's going to link 15th century Renaissance to 21st century interoperability. So with that, thank you very much, everybody. Hope you enjoyed the final keynote of it and have a wonderful day.
Thank you, everyone.